Okay, so now we can proceed with our second session. My students, now we are talking about that concept of an ion. Tumeona kwamba an ion has a large atomic radius or atomic size once you compare it with the neutral atom. Why? Because it involves the addition of the electrons. Maana kwamba always negative charged ion, they tend to gain electron in order to maintain its stability. Kama zina gain electron, maana kwamba kutakuwa na addition of the what? Of the electrons. So you can see that they experience the higher radius size or ionic size once you compare with the neutral atoms. Also, an ions, the nuclear attractive force is distributed to a large number of electrons. Sasa anasema kwamba pia kwenye hizi ions unaona kwamba ile nuclear attractive force inakuwa distributed to the large number of electrons. Kwamba inakuwa distributed, it's like inagawanyika. Inakuwa distributed ambapo kuna large number of electrons. So this is a result, the electron experience weaker nuclear attractive force compared to the neutral atom. Sasa kama unaona kwamba kwenye ions hii nuclear attractive force inakuwa distributed kwenye large number of electron, therefore itapelekea nini? Itapelekea electron to experience the weaker nuclear attractive force ukicompare na zile ambazo ni kwenye neutral atoms, ukicompare na neutral atoms. So this weaker nuclear attractive force are also attributed to an increase in the electron repulsion due to the additional electrons. Sasa hii weaker nuclear attractive force ambayo inakuwa formed hapa, pia inaongeza au inasababisha increasing in the electron repulsion, kwa sababu kuna zile increasing of the what? Increasing of the electrons, zile additional additional of electrons. That's why anasema kwamba also attributed to an increase in the electron repulsion due to the addition of electron. Kwamba kutakuwa na zile addition of electron. Therefore you can say that this electron repulsion will increase. It will increase. Kumbuka hapa tunaongelea kuhusiana concept of an ion. So now you can say that therefore the general trends in ionic radiation. Sasa ili sasa tuangalie ile trend sasa. I hope you get the concept of ionic radiation. Sasa now let's refer to our trend. Kumbuka our main concern is the periodic trends in the physical properties of a different element. Therefore sasa tunakuja kwenye kuconsider au kuangalia the issue of the trend now. Anasema kwamba therefore the general trend in ionic radiation is the same as that of the atomic radiation, which decrease across the period. Kwamba tunapokuja kuangalia hii trend of the ionic radiation ni sawa na ile atomic radiation ambayo always across the period it tend to decrease. Kwa sababu anasema kwamba which decrease across the period. Maana kwamba when you move from left to right across the period, this ionic radiation tend to decrease kama tulivyoona kwenye atomic size or atomic radiation. Why? Because anasema this is due to the increased effective nuclear charge. Across the period, when we talk about ionic radiation, there is increase of the nuclear charge. So as long as the nuclear charge increase, also this atomic radiation will be lower or will decrease. Simple, because you can see that all electrons will be bonded or will be holded to the center of the nuclear. Kwa hiyo ile distance haitakuwa formed kwa sababu hatutakuwa na zile most or the main electromost shells. Hatutakuwa na zile main shells. Therefore you see that the distance will be lowered, and therefore that's why the ionic radiation decrease across the period. And also increase down the group. Why? Because of the increase in the number of the shells. Sasa kama utakumbuka vizuri, kule tulizungumzia hii concept wakati tunazungumzia the trends in the atomic size. Sasa ndio maana hapa nakwambia the general trends in ionic radiation is the same with that of the atomic size. Kwa sababu tunaona kwamba okay, when we come in the issue of across the period, the ionic radiation tend to decrease. But when we come in the issue of the group, down the group, the ionic radiation tend to increase. Why increase? Because there is the increase in the number of shells. As we go down, we can move from one period to another period. Therefore utakuwa na shell ya kwanza, ya pili, ya tatu, ya nne na kuendelea as you move down the group. That's why you can see that down the group the ionic radii tend to increase, while across the period the ionic radii tend to decrease. So that are the main trends for the ionic radii. So I hope that is clear for you. Haya ndio maswali ambayo utaulizwa kwenye mtihani. Utaambiwa describe the trends of the ionic radii across the period and down the group. Kwa hiyo jibu ni very simple. Very simple. Unamwambia tu across the period the ionic radii tend to decrease, unatoa na sababu. Kwa sababu there is increase in nuclear charge, so inapelekea zile molecule au electron kuwa holding to the center of the nuclear, therefore the radii decrease. But also down the group there is increasing in the ionic radii. Why? You have to provide the reason. Because there is an increase in number of shells. Only that. Kwa hiyo utaona kwamba you are clear. So now let us see about the ionization energy. Ionization energy. As we see that this is among of the physical properties in of the different elements. So in our trends also we have to talk about this. So in order to remove an electron from an atom, energy must be applied to overcome the electrostatic force of attraction between the electron and the nuclear. Sasa ili tuweze kufanya removing of the electron, there must be application of the energy. Lazima energy itumike. Ile energy inatumika kuensure that tunaweza kuhandle ile force of attraction ambayo imehold zile electron na nuclear. Kwamba zile electrons zimekuwa bonded au zimekuwa holded to the what? Near the nuclear. Kumbuka ile force of attraction nuclear na zile electron itakuwa ni very greater. So in order to overcome that situation, we have to apply the energy. In order to remove those electrons. So this energy is called the ionization energy. Sasa hii energy ambayo itatumika sasa kuweza remove electron ambazo zimekuwa bonded au zimekuwa holded closer to the nuclear, tunaita ni ionization energy. Ionization energy. So ukiulizwa what is ionization energy, and this is not a new term, tumekutana nayo sana wakati tunasoma general chemistry. Tumeisoma hii concept ya ionization energy, lakini tulikuwa tunazungumzia with the context of the general chemistry kule. The same apply kwenye physical chemistry. Tulisoma concept ya nini? Ya ionization energy, lakini pia ilikuwa ni kwenye context ya kwenye physical chemistry. Kwa hiyo hapa pia kwenye inorganic chemistry we have to relate or we have to explain depending on the context of the inorganic chemistry. Lazima tueleze kulingana na mazingira husika. So the ionization energy is the minimum amount of energy required to completely remove 1 mole of the electron from 1 mole of the gaseous atom or ion. Sasa in order to define now this ionization energy, this is the minimum amount. Ni kiwango kidogo cha energy. Minimum amount of the energy ambayo inakuwa required, inahitajika ili kuweza kuremove the completely 1 mole of the electron, kwamba tunaondoa 1 mole of the electron from 1 mole of the gaseous atom or ion. This is what we call ionization energy. Na maana yake itabaki kuwa hii quote. Sema tu hapa we are talking about the issue of the removing electron, lakini the same things. Hata kwenye zile contexts za physical chemistry and general chemistry lazima uweke hii minimum amount of energy required, lakini inafanya removing of what? Kutoka kwenye atom gani kwenda kwenye atom ipi au hivyo. So you can see the same things. So it is expressed in kilojoule per mole. This energy is expressed in kilojoule per mole. The lower the ionization energy, the more easily the atom become a cation and vice versa. Kwamba ile ionization energy inapokuwa kubwa ndivyo the more cations are formed, and if it is higher or vice versa, the same this cation, it will be difficult to be formed. So ionization energy is determined by the atomic size, nuclear charge, screening or shielding effect, electron locality in orbitals and electronic configuration. Sasa hapa tunakuja kupata new concepts. Tunapata new concepts kwamba tunapozungumzia ionization energy, you can see that anasema kwamba it is determined by the following. Kama tulivyoona kule kwamba atomic size inakuwa determined by atomic radii, tukaja kuona kwenye atomic radii kuna vitu gani, vyote tulivisoma. Sasa na hapa pia tunapata the new concepts kwamba kwenye ionization energy it is determined by the following fact, that there is atomic size, there is the nuclear charge, there is a screening or shielding effect, there is electron locality in orbitals, but also we have the issue of electronic configuration. So my students, we have to discuss one after another about these factors which are useful to measure or to determine the ionization energy. And then we will proceed in the next session. Then after, I would like to say this marks the end of our both discussion, session 1 and session 2. Thank you so much for watching our Media Educare TZ. Bye bye.